Hi everyone, we're on section 8.3 and this is about triangles, hexagons, and irregular polygons. We're going to start out with triangles, and so we've talked about some triangles before because we talked about the fact that the angles add up to 180, and so triangles have three sides. As you can see here, they have three angles. An isosceles triangle has two equal sides, and it also has two equal angles. So if you have the angles that are the same on this bottom part, then you're going to know that that's an isosceles. Of course, it can be turned sideways. It doesn't have to be on the bottom. An equilateral triangle means all three sides are equal, and also all the angles are the same. Each of them are 60 since they need to add up to 180. And then a scalene triangle has three sides that are different. None of them are equal. And so isosceles, equilateral, scalene, we're going to be working with some of all of these as we go through this lesson and beyond this, because sometimes when the shapes are put together, we're going to be dealing with those more. And then we have some of those in chapter 9 whenever we're finding volume and surface area of prisms and things like that. Here's some more. So an acute triangle means that all the angles are less than 90 degrees. And then an obtuse triangle has one angle that's greater than 90. You can see that here, right there, right? That's the angle that's greater than 90, but that, of course, the other two have to be less than 90 because the total is 180. And then a right triangle, of course, has one right angle. The hypotenuse is always opposite that right angle. So whatever side is opposite the right angle is also the longest side because it's opposite the biggest angle in the triangle. The legs are perpendicular. You can see here that it's pointing at the legs, and we've got this symbol that tells us that it's a 90-degree angle, and also that means that the sides are perpendicular. We call this longest side the hypotenuse, and that's going to be important in different things that we do for the rest of this class. Okay, so we're going to talk about the Pythagorean Theorem, and this is just basically a formula where you can find the length of a side of a right triangle. So this is only for any right triangle, right? The square of the hypotenuse is equal to the sum of the squares of the two sides. Now, the A and the B, it doesn't really matter which side we call A and B as long as it's the two sides that are perpendicular. And that's how we know that those are the sides of the triangle, and then of course the hypotenuse always opposite that right angle. And then we use the formula to find a missing side when we need to. And we're going to do that here. So this one says find the distance D, here's D, between points A and B for this rectangular plot of land. We can see right here that we have our right angle, and it's opposite side D, which means that when we use our formula, we're going to be finding the hypotenuse or the C. So in this case, we can name these whatever we want as far as which side is A and which side is B. Let's do this, and then we'll call this side C, where the D is located. Okay, so my A is 20 feet. B is 36 feet, and C is what I am looking for. And of course it will be a measurement in feet. So we set it up as C squared equals A squared plus B squared. And then of course we use our calculators to calculate 20 squared is 400. 36 squared is 1296, and then when we add those together we get 1696. Oops, that's still C squared there. Let's go back here. So I'll go ahead and say C squared one more time. 1696. So to solve this, we take the square root. If C squared is 1696, then C will be the square root of 1696, and that is 41.18. We're going to round it to 41 feet and round it to the nearest foot. That's how the other units were given, right? They were both rounded to the nearest foot, so we'll do the same thing here. All right. Now sometimes we're finding one of the sides and we know the hypotenuse, and so these are just different forms of the same formula, the Pythagorean Theorem. Solve for C, solve for A, or solve for B. Now, you don't have to know these or anything, but it could be handy to have if you want to put it on a formula card or something, or your notes for the test. I usually just give you this one on the formula sheet that I give you. So if you want these others, I would write it there. So let's call this one A and B, and of course this one's C because it is the hypotenuse opposite that right angle. You can always draw that arrow to C. So we're going to use the formula for A this time. Basically, the solving part of it has already been taken care of, and we just plug in our numbers. So we have C squared minus B squared, right? So we're using this formula, or this form of the formula, right? And that gives us 144 minus 100, the square root of 44. That wasn't really supposed to be a wavy equal sign, just a regular one. When we take the square root of 44, we get 6.63, which is about 6.6 feet. It says round to the nearest tenth if needed. And so that is the side of that's our shortest leg, right? The side of the triangle, a leg of the triangle. And it's important that you understand which ones are legs and which one is the hypotenuse. All right. Now, on this, we're going to be talking about the area of a triangle. And we have it written a couple different ways. The one that I like the best is this one, 1/2 the base times the height. So that's usually what I'm going to use whenever I'm working the formula. But you can, use either one. The base is always going to be the side that is perpendicular to the height, and that's an important part of that because we have to figure out which numbers do we need here. And so on this it says find the area of the triangle. Well, we don't need these links for area, right? If we're finding the area, then we simply need to know the base and the height. So this is our base. What is going on here? It's not letting me write here. I'll try to write. Our base is 13 and our height is 8. In our formula, we're going to say 1/2 the base times the height of 8. And usually, because I'm not using a calculator, 1/2 of 8 is 4, so this is going to be 4 times 13. You can just key it in, and that would be 52. Now this is area, so of course it is square inches. Because my units were inches and it's area, so we square them. Here's another triangle, and on this one we weren't given any extra numbers. Oh, by the way, if you needed to find the perimeter, you would just add the 3 sides. We've already learned that we can do that on perimeter. Okay, so on this we're going to put in 20 for our base, and 12 will be our height. And you can see that even though it's drawn outside the triangle, it's perpendicular to the base. So 1/2 the base times the height. 1/2 of 20 is 10, so we're going to take 10 times 12. So we get an area of 120 centimeters squared. Okay. Now this is a formula that I've never really personally used much. This is a formula for an isosceles triangle when you don't have the height. Now, we could actually find the height now that we know Pythagorean theorem. And so if you would prefer to find the height, you could do that. You would just look at your triangle here, and your height's going to have to be drawn perpendicular to the base. So that's what you would do. Each side of that, right, that would be right in the middle, would be 2.5 feet. So it is possible to go ahead and find your height and then use it in the formula. You would get the same thing. So this formula is solved in such a way that we don't need the height, and we can just plug in the numbers. Now, the part of it that might be a little bit confusing and something else you might want to put on your notes for a test is which sides are the A's? Well, A's are the two sides that are the same, and then B is our third side. Remember, this is an isosceles triangle, so we'll always have two sides that are the same, and that's going to be the values that go in for A. Now, it's kind of a weird formula. So my A is 10 feet and B is 5 feet. And if you work with this formula a little bit, you'll probably understand how it is written here. So it is solved for finding the height. So 1/2 of B times the square root of A squared minus B over 2 squared. Notice we were taking this B and dividing it by 2 to find the height, right? So that might help make sense. And then let's work through this a little bit more. 1/2 of 5 is 2.5. Oh, I put a B in there, so hey, let's put a 5 because we know B. Okay, so it's going to be 10 squared minus 2.5 squared, or 5/2. You can do that if you want to. I'm going to go ahead and change it to a decimal. And then I'm going to take 2.5 times 93.75. Now, you might feel like, oh, that's a lot of steps. You can simplify some with it. You could go ahead and do some of these steps together. I would just suggest that you don't try to shorten it too much, that you go ahead and work out some of the steps, because sometimes when you don't, then you end up with a number that, you mess up on your calculation, basically. When we take 2.5 times the square root of 93.75, it's 24.2, and I'm going to round this to a whole number, 24 square feet. And then we're finished with that one. Let's see. And then this next one is an equilateral triangle. The formula is a little less messy. A is going to be any of the sides, because remember, when it's equilateral, the same thing happens here. Once again, we could find the height and just use base times height, right? Because we could take 11 centimeters and use the Pythagorean theorem to solve for one of the sides. But let's just use this formula. So A is 22 centimeters. So using this formula, and I do put these formulas on the formula sheets that you get to use for test, we're going to take A squared times the square root of 3 divided by 4. But that also is 0.433 times A squared. So I would actually rather just go to that. So let's do that. Now that's approximately, because they've rounded, the square root of 3 divided by 4 is what we've got there. And so we're going to say 0.433 times 22 squared. So you can do this or just go straight to that. If you take your calculator and put in the square root of 3 divided by 4, then you'll see that it's 0.433012, and it goes on to a bunch of other numbers. And then the main thing here is, can you recognize that this is an equilateral triangle? Because that's important that you can do that. So it's approximately 209.6. I'm going to round that to 210 centimeters squared to a whole number. And then I'm going to stop this video and pick up the lesson on the next one. Bye, everyone.